Now, let's talk about functions and relations. Last time, we talked about functions. And when we define a function is usually it is an expression, it is a rule, or it is a law, wherein we are associating a variable to another variable. In short, there is always an input and there is always an output from the given input. While here, we are also going to talk about relations. Are we sure that functions are relations, or relations are functions, or they are not? Okay, so let's talk first about what's the meaning of a relation. A relation has three kinds. We have one-to-one relation or one-to-one correspondence. So for example, let's say we have here your x and your y. For example, we have your x, 1, 2, 3. X is paired with A, your 2 is paired with B, then 3 is paired with C. This is an example of one-to-one correspondence or one-to-one relation because there is only one unique element or pair for any values of your x. So for 1, we have A down to 3 corresponding to C. So this is a one-to-one correspondence. Next, we also have here one to many correspondence or one to many relation. For example, here we have here let's say we have 2, then 2 will be paired to, let's say, negative 1. It will also be paired to negative 2, and it will also be paired to, let's say, negative 3. This is one to many correspondence because there is one value for x. However, there are so many values for y. So from the name alone, one to many relationship or one to many correspondence, there is one value of x. However, there are different values of outputs from one main input. Okay, and the other one, we have many to one. We have many to one. We have many to one correspondence. So how is this? For example, let's say we have Apple, we have Samsung, we have Sony, and let's say we have here uh, Huawei. Okay, so here, this is ultimately talking on one specific description, talking about brand of phone. Let's say here, brand of phone or phones. This example is corresponding to many to one. So we have here, this is your input, and you also have here your output, which is simply brand of phones. Now class, looking at our example here based on relation, a relation is simply, it is a connection of one variable to another variable. In short, it is an association. We're going to find out if there is an existing relationship between or among the different variables. Now, if we are going to relate it with functions, by meaning, a function is simply a relationship between independent variable and dependent variable, okay? And when we are talking about function, there should only be unique element for our input. And our unique value for our input is known to be our independent variable, which is usually denoted by x or x. Now, in our example, from our different relations, kinds of relations here, one to one, is this considered to be a function or it is simply a relation? By meaning of function, take note, by meaning of function, there should only be one unique element for x. Okay, your x, in short, should not be repeated. Okay, so here, one-to-one correspondence. One-to-one correspondence is a function. This is a one. This is what we call a function. Okay, this is a function. Why? Because we have here 1 is paired to A. Then 2 is paired ultimately to B, and 3 is paired to C. And our x here is not repeated, okay? There are no values of our x or some way or somehow are not repeated. How about here? Let's try to look at our many-to-one correspondence. Is this the function or relation? What do you think? Try to look at your x, this part. Okay, so we have here the different brands of phones. So Apple is a brand of phone, Samsung is also a brand of phone, Sony is also a brand of phone, then Huawei is also a brand of phone. What do you think? This is also a function. Okay, class, this is also a function. Why? Because our inputs, which are known to be the brands of phones, are never repeated. Okay, they are not repeated. How about here? One to many. What's this? Is this a function or a relation? What do you think? Okay, one to many correspondence is a relation. Okay, it's a relation simply because when we are talking about the definition of a function with respect to your x should not be repeated. In our example here, we have 2. 2 is paired to -1. 2 is paired to -2. 2 is also paired to -3. If we are going to put this in terms of ordered pair, this would become now 2, -1, 2, -2, and we have 2, -3. And based on definition, our x should not be repeated. Okay? If there are values of your inputs or your independent variable, whenever they are repeated, then they will never become a function. They would be termed as simply a relation class. Okay? So that's all about relations and functions.